Great presentation. Steve Levy, what were the approved ATPs that you used as the thresholds? And secondly, when you look at non-resistant staph, would this be a much better cleaning methodology to help curb the reproduction of bacteria that is growing because they're using a lot of poisons?
A couple of very different questions there. At the time we were working with ATP, we really didn't have a lot of information to work from. As I mentioned earlier, we steal good ideas, and we took that actually from the food industry. And at the time we were working early with ATP is that we were using food standards, and I believe that 150 relative light units was that used in cold meat, delicatessen type sandwich making category, and we bought into that. That was our target. If it was safe enough to eat from, then it was safe enough for us to provide patient care. On the second part, I'm not a microbiologist, but my sort of mantra is get it out of there. I'm not on the search and destroy process. I'm actually advocating balance. I'm a naturalist. We will never defeat, as Stephanie said this morning, we will never defeat these microorganisms. They're too smart, there's too many, we don't know most of them, and we don't know what's there that we're dealing with, so we have to work to the lowest common denominator. As long as we continue to go out on a kill basis, we will kill the weak, but the strong will remain, and they will recolonize. My rationale is if we can find a way to balance things out, we can have a sort of a balanced microflora, if you will, then we're in pretty good shape. And then strategically, we can go in when necessary. So when a bad guy does show up and colonize, then we have the tools available at our disposal. We haven't created any insensitivity or resistance. So when we do use the chemicals, they're effective and they're rapid. So that's a notion. As I say, I'm not a microbiologist, but that's my notional intent.
Bill Griffin, Cleaning Consultants. When you did your aerosolation tests, did you always have a vacuum component involved in that, or did you do any tests without the vacuum component involved? And then secondly, when you went from the cloths to the actual disposable microfibers, did the cost go up or go down?
Sorry, the cost?
Costs go up or down in the process of materials?
I'll start from the back first. We had to work from a cost basis, is that we are working very hard to implement a disposable program which is equal to or better than conventional reusable. But that's based on life cycle costing, or cost per use, including the energy costs and the handling of laundry. Does that answer your question about disposable?
Was it up or down?
We're working down. We're there. But we think we can do better. And part of my future is actually I'm going back to do some work at the University of Manchester Textiles Department. We think we can do better. And we have the support of Professor Chris Carr there, who's a fabulous, energetic and enthusiastic guy. And I'm very, very convinced that we will find some enhancements there. On the second part, we did use vacuum. Those that were running at 28 liters a minute to draw air from the test area onto the actual plates themselves. But the rest of the unit, there was no air movement whatsoever. We actually were working in a still air environment apart from our own activity.
So did you ever do any testing without the vacuum unit?
We did the original tests using settle plates, where we would do the cleaning, then vacate the room and allow the room to settle for 60 minutes, and then come back, recover our plates, take them over to the lab and incubate, etc. But it wasn't seen to be a strong enough test. That was T&O's opinion. Does that answer your question satisfactorily?
Well, did you always use the vacuum, or did you do tests without the vacuum unit as part of the component?
Sorry.
And what were the results if you without?
Without, with settle tests, we could not detect any spores. There was no dispersion and there was no settling out onto our plates. So we took that as being a very successful test. But the academics who reviewed that data said not strong enough. We want to get closer to the actual dynamic cleaning activity, because we were working within the space between normal patients, but we know that once things are aerosolized and spores are only 1 micron, they have an ability to transfer quite a number of feet through an area.
Hi, Peter Sheldon.
Hi, Peter.
Quick question on the specifications of the microfiber, what you've termed as ultra microfiber. Can you comment on what the specifications of that product is, as well as a little definition on the J-type cloth that you list? And then secondly, what I want to know is, at what point do you have a trigger mechanism to move from a standard reusable microfiber cloth to a disposable due to the issues with the spores and the releasing of that?
Interesting questions. Again, as I say, we steal good ideas, and we borrowed from Scandinavia on the ultra microfiber. They've been using the ultra microfiber for 12 years or more now. We have adapted to use less expensive microfiber, but that was an 80-20 blend. Ultra microfiber is defined as 0.3 decitex. So 1 gram will go 1 kilometer. I think I'm not a textiles expert, but it's to do with the fineness of the actual microfiber itself. So that translates into surface area. And what we were extracting from the microfiber was huge surface area with ability to adsorb from a surface and encapsulate. So that was part of our strategy to remove from the surface.
Specific weight of the cloths and things that you utilize?
Yes. I can't quite remember what the specifications were at the present moment. I think they were 600 grams square meter, I believe. But I could stand to be corrected on that.
Last question.
Yes.
Yes, sir. John Richter from
Hi, John.
Tyvek. Question is I know that removal's important, and a lot of what you were doing was measuring, the plate counts, which is actually measuring live. I'm curious what tools you were using to measure the removal aspects, and what were the results if you did do that?
It was simply microbiological measures. Is that we knew that we'd laid down a load on the target surface. We employed the standard operating procedure. We measured before, so we had our control. We used the process, and we measured afterwards. And
I'm curious, is that there's a kill that's taking place with them?
not necessarily. On some organisms, they are sensitive to the heat. I didn't have the heat tables up there, but depending on the tool, you're ranging between 85 and 130 degrees. Not all organisms will be addressed by that, and certainly not the contact time that we're working with. We're talking about dynamic cleaning here. It's active, it's moving.
Use the ATP to measure removal at all?
No. We use selective agar plates. We cultivated each organism that we could actually just recover from the surface. So that was the strongest test that we could actually take. Yeah.
Okay. We are at the break time. Let me take the chairman's license to add a personal note. I'm smiling. Michael Rollins said some of the ongoing research will be at the University of Manchester in England. In 1967, that's 40 years ago, I did my PhD at the University of Manchester in polymer and fiber science, polymer physics, but much of my work was with the textile technology, world-renowned polymer physics group and world-renowned professor in textile technology and fiber science at Manchester. I'm a New Yorker. I'm not a Brit, but I got a great education at Manchester, and it's a love of mine. So anyway, it brings it back. Join me in thanking Michael Rollins. We will restart. Promptly, please, at 3:15, we reconvene.